Welcome to another Protastructure tutorial video. This is a real life project. In this video, we will be considering the modeling of all structural members of this structure. We will also model the steel roof, trussed successfully. We will load the structure, analyze, and design all of the structural members, and we will proceed to carry out the foundation design in this video. So stay tuned, go nowhere. But before we proceed, I want to please with us to like the presentation. If you are yet to subscribe to this channel, of reason, kindly do so. Hit on the red subscribe button and turn on the bell notification icon so that each time we upload a useful content like this, you will be the first to get alerted successfully. I am engineer IC Friday, your instructor. I want to also invite you to join our masterclass training program that is ongoing. This training program will make you an advanced user of this program, Protastructure, Tekla structure, and other software we are teaching on this channel, of reason. We are going to train you from A to Z on the use of this program. We train and expose how to use all kinds of foundation, all types of foundations using this program successfully in that masterclass training, and as well how to carry out more sophisticated modeling or complex modeling using this program successfully. So at this extent, let us dive into the modeling of the structure. But I would like to let you know that we will be considering an AutoCAD template for the design of this structure. I grant you the permission to share this video with your friends as it may help them in one way or the other. Let us make progress. We are going to be creating a new project with a template file. So you click on the file menu right there, come to the new project right there. So we click on the yes option to save this. Here is a new project dialog, so we have to make change to the project name. So we change this 1 to 2, just like this. Okay, so for the code of practice, just as I've said earlier, UK AutoCAD will be using, and the template, click on the OK option. So here we have the AutoCAD template being created successfully. We'll start the modeling by creating or setting out grid lines successfully. So get to the modeling tab right there, click on the orthogonal axis generator. Pick any point in the scene environment to have orthogonal axis generator. Now direction 1 axis is always the horizontal or the x-axis directions, while direction 2 axis is the vertical or the y-axis direction. So we will be having in the x directions the first spacing of 6,000, alright, and then it is going to be followed by a comma. So we have the next space to be 3 meters, which is 3,000 millimeters right there. Okay, so for the vertical axis directions, we will be having the first to be 1,300 right there. So we have comma right there, and then we proceed to have 5,000, right, just like this. So we have an asterisk 5,000 into 3 right there. Okay, then we have a comma right there, and then we still have 1,300 just like this. Okay, so this is the grid line set out of the structure successfully. All right, click on the OK options, and you have something of this kind, you can see. All right, so at this point we will proceed to insert the reinforced concrete columns. So click on the columns member right there, and then in the dialog we will go by the column sections 500 by to 50 right there. So we have to highlight all of the grid line intersections for ease of placement of the reinforced concrete column, but I wouldn't know how the orientations of the column will be, so I have to check. Okay, see the orientations. I wouldn't like these orientations. I want it to be in a vertical orientation, so I will click on this manager and then rotate it this way, this direction. Click on the OK option. So at this point we will click right here, do a window over all the grid line intersections, click to release your hand, insert all the reinforced concrete columns just like this successfully. Alright, so click on the close options. We proceed to insert the reinforced concrete beam members, come to the modeling, and then under the ROC members you can see the member right there. Click, and then we will be having the sections to 50 by 450 right there, so we change here to 450 successfully. Okay, so we have our beams connecting this external column successfully just like this. We have beam member connecting this, so we have another one. Zoom closely to be able to pick the grid line intersections right there. Okay, and then on grid line 3 you have the beams as well as grid line 4. Alright, you pick it once, take it to the next column, pick it. Alright, so to get right of the command you have to right click right there to get right of the command, and then you can proceed placing it. Okay, just like this. Okay, if you have any questions, don't hesitate to drop it in the comment sections successfully. I will attend to all of your questions accordingly. Alright, so we have set our columns and beam members successfully. The next thing we will be placing on this is going to be the reinforced concrete slab. Alright, so we navigate to the modeling, tap again ROC member, slab right there. Okay, the thickness of slab we considering is going to be 180 slab thickness. Alright, so slab type, the program selected automatically. Alright, so we don't have any need selecting, okay, according to the rules or boundary conditions. The program will do that successfully. Slab level positions, we use this center point, go to the loads options, and then we will consider lower slabs options. This one, you select that successfully to apply the additional dead load on that. So this is a commercial structure, so we'll be considering 2.5 kilonewton per square meters for the imposed load successfully, just like this. Okay, so at this point we start to place the ROC slab just like this. Okay, alright, so having placed that at these provisions, we want to change the slab type, so we have to close this. Alright, get back to the modeling, and then we'll be considering rib slab right there. So click on the rib slabs. So for the BW of the rib slabs, we will be considering 125 right there. So for this we'll be considering 300 right there. Alright, so for the X blocks, okay, which is the spacing right there, we consider that to be 300 right there. Then for the edge slab, which is the little slab thickness, okay, on that ribs, you have it to be 50 right there. Okay, so we check the loadings right there. So over here we consider lower slabs, just as we did in the other provisions. For the imposed load we used 2.5 imposed load right there. Okay, so we want to actually set the orientations as well. Let's check the instructions. Okay, it's going to be set at default. So the orientations of these will be placing it just like this. So we go by these orientations of the ribs just like this. Okay, so we have this because this is going to be used to form a stairway. Okay, and the steps where the viewers can actually comfortably sit successfully. Okay, so click on the close options. So at this point we will proceed to set the stories. So setting the stories, we will have to navigate to the stories provisions. So let us try to minimize this right like this. Okay, so come to the stories, right click, edit stories just like this. For the foundation depth you maintain 1100 right here. Okay, so for the story height is going to be 3 meters, which is 3000 millimeters. Structural system is going to remain ROC right there. So after which we click on the OK options. and yes options. Since we are having two floors, we want to as well generate stories or insert stories as first. So you click on insert stories. We have two floors plus the roof level, which is going to be 3 floors. So you key in 3 right there, click on the OK options. So you navigate back to the populated story, which is story 1 right there to have this. So at this point, we want to be applying plane definitions to the slopey provisions. Okay, so because these provisions are actually going to be slopey, right, because it is a pavilion. All right, so we click on these plane definitions right there. So in the plane definitions, we want to be applying the plane definitions to this successfully. So we can take this to be plane 1. Yeah, plane 1. We take this to be plane 2, which is P2. Plane 3. Okay. So what happened is this: we may applied a plane definitions to P2, then use it to replicate the rest of that, so it will save time actually. All right, so let's proceed. So we close this at first. So for P1 right there, we have to select the P1 so we can make some editing. All right, so we right click on that, select it, right click, click on each property. So in the property, we will need to anchor point 1 to these provisions. Click here for point 1, click on update, anchor point 2 here. Alright, click on update, then for point 3 you have to anchor it up here. So this is going to be maintaining the normal 3-meter levels. Okay, this point will maintain the normal 3-meter levels. So we will now be making changes accordingly to the P1, P2. Alright, so for P1 we are having to slope that point downward. Is going to be taken as 1800 right there for point 1. Okay, so for point 2 we still have to prefix minus 1800, just like this. Click on the update. So you see this provisions is being updated successfully, so click on the close option. So we navigate to the P2 right there, select P2 right, click on it, and then it properties, and then we need to set the points. Okay, we anchored here P1, update right there, anchor here to P2, and then zoom closely so you can pick the right intersection point. Okay, update successfully, then P3 is going to be on a plane level. Okay, so we place that here, so zoom closely to it, just like this, and then click on the update right there. So after which we are going to be sloping this, okay, downward. So it's going to be prefixed with minus 1500 right there. Okay, just like this. All right, then P2, which is the point 2, minus 1500 as well. Okay, so click on the update right there. So I haven't done for these two. I click on the close options, and then select this P3, right click on it. We have to delete this plane successfully. Then we use the plane 2 to replicate every other plane. Click on this property, so we just have to place it here to have a P3 right there, and then place this to have a P4. All right, close this. We use this property of P1 on the other provisions, so click on each property right there, come over to these provisions, click right there. So it is not actually showing us the plane. All right, so we sorry, close this right there. Let's get the plane selected. Okay, so select the plane just like this, right click it property. All right, so this is not the plane, this is selecting the rib. Okay, we need to get the plane selected, this one, right click property. All right, like this. Okay, then you come over to these provisions and insert it, which is P5. All right, so having set the plane successfully, just like this, what you need to do, let's navigate to the 3D right there to see what we have successfully. So we have something of this kind. So we want to be inclining the plane successfully to the set slope. Okay, so select P1, right click and click on the move member to plane. So yes options right there to move this, just like this. All right, so do the same thing to P2 and then move member to plane. Yes options, just like this. All right, so you proceed to P3 right there, you move member to axis. Yes options, and then P4 we move member as well to axis. All right, click right there. Yes options. Okay, so P5 the same thing. Yes option. All right, so having done this, okay, the next thing we need to send the ROC columns, this plane we have to edit it again. We need to get this downward the way it is. Alright, but before then, let us work on the reinforced concrete column. Select this. We wouldn't want it to move with the plane sloped figure. So click on its properties, come over to 3D right there. You have to cancel that slope, update this to take this column back to its normal height. Right, so the same thing is applicable to this, but you can select all of this to ease the working experience or the control key. So you can select multiple of the reinforced concrete column, right click, select its properties. All right, just like this, and then in these provisions where you have this digit up, select right there, and then click on these provisions, click in 0 right there. So this has changed and it will returns all the columns to its normal level. Close this to have the columns just like this. All right, so we need to make the entrance staircase more slopey than this. So what we need to do, you navigate to the story 1 right there, get to the plan view of the story 1, and then you pick this plane P5. You make sure this plane is rightly selected. Okay, and right click and get its property. Over here we have 1800. We will be adding addition of 600 to this, which we actually give us 2300 right here. All right, yes, 2400 will be having right there. So you key in 400 right there. Okay, so 2400 in this provision as well. Click on the update. Okay, after which close this, and then let's navigate to 3D and take what that actually results to. Okay, so we have this. All right, at this point we need to get the plane 5 right there, move member to plane like this. So we have something of this kind. So this is what we actually intended. All right, select two of these reinforced concrete columns, right click, get to its property. So here we have this figures, change it to 0 right there, and then click on the close options. So we have something of this kind. All right, okay, so having done that, in that provisions we come over to this other provisions, navigate to the plan view P1. All right, we also select this plane, make sure this plane is selected, right click, hit properties, and then change here 2400. All right, come over to these provisions and also 2400. Okay, so click on the update options and then close options, get to 3D again, and then we get to the plane provisions, expand the story 1. All right, get to this plane provisions, which is the P1, select it right there and move member to plane, yes options, just like this. As well, remove the plane constraint. Okay, the constraint of 2400 downward have to be removed. Okay, change it to 0 like this. Okay, so we have this. All right, so this is what we actually intended. So at this point we want to be modeling another staircase provisions here. All right, so this is the entrance staircase. If you are going to the next floor, all right, you have to pass through this one, that this will be provided here. Okay, so we navigate to the plan view, so we insert that successfully. So to insert this, we're going to be considering a beam. All right, so for the depth of the beam we are going to be considering is going to be a beam of depth 4100. All right, so this beam is going to be anchored from the foundations. Okay, going to be anchored from the foundations. So how do I get this 4500 is gotten by adding the foundation depth and the story height to get this. Okay, so I'll be using a curve beam insertions options, this one. So pick the first point, pick the second point, move your hand this way to get a radius. Okay, so you can do shift F2 right there to be able to key in the desired radius, which I want it to be 1500. I hit on the enter to have my curve beam placed just like this. All right, so I can decide to mirror this beam to this other side. So how do I do that? Okay, so I can select this, make use of its property. So see mirror options there. All right, it can't actually works, but I want to just model it here, this side successfully. So this is axis. All right, I want to select beam, so make sure the beam is selected successfully. So you just click on its property and then come over to this side, hit on the intersection grid line C and B. All right, right there, move your hand this way. Sorry, I have to pick the instruction method to be curve beam. So pick the first point, pick the second point, and then shift F2. All right, to have a provision to key in the radius of the beams right there, like this. Okay, close options. Alright, so at this point we can navigate to the 3D to see what we have done so far, just like this. So we have something of this kind. Alright, at this point we can now proceed. We are going to be generating these stories. Okay, so we are to navigate to the structural tree right there, and then we just have to minimize all of this. Okay, but before we generate story, let's try to close up these provisions. So there are two ways you can actually close up that provisions. It's either you can actually place another beam right there, or you can increase the top constraint of this beam. So if you increase the top constraint of this beam, it will as well try to close up these provisions. Alright, but we can use the property of this beam. So select this one, right, that beam, so get that selected, and then or this one, right, any of this, right click and then pick its property, and then pick the first point right there, come and pick the second point. You see it placed successfully, just like this. Okay, so we have this place being modeled successfully, just like this. You can see. Alright, so we can do that over to the these provisions, use the property of this beam, and then click on this property, pick the first point right there, pick the second point to have the beam placed, just like that. Okay, alright, so at this point we can now generate this to other floors successfully. So we click on the stories right there. Mind you, you can also go to building setout, you see stories operations right there, and then you click on the generate story. It is the same option you have here. So at this point we will take this to the second floor. From the first floor we take it to the target second floor. So at the second floor we need all of these members types to be generated as well. Okay, so click on the okay options, and then yes options, then you have this, alright, being generated just like this. Okay, so if you check this, you have to check to make sure that you wouldn't have any overlapping right there. So all of these columns are properly placed successfully, just like this. You can see. Alright, so but at this story we wouldn't have plane. Okay, we didn't have this slopy entrance way, because the entrance is now going to be from this. Alright, from this there will be a staircase inside of this provisions, inside of this small room. Okay, that will take the viewers from this first floor to the second floor successfully. So if you check very well, you notice we are having a kind of overlapping here. So you select that, right click, properties, and then you will change it 4100 to 3000 millimeters or 3 meters update to get rid of that overlapping. Alright, so over to this side we do the same thing, select that, right click. Okay, so we have to change 4100 to 3000 millimeters. Click on the update right there, close. Alright, so at this point we want to we want to change the actually change the plane definitions of P5, and as well as plane definitions of P1. Alright, so let's navigate to the plan view. Alright, so at the plan view, before we can do that effectively, we need to get rid of these beams, because this plane is not actually showing us. There is no way you can be able to get the plane, so you have to delete the slab at first. You get the slab deleted just like this, and then you also have to delete the beams first, and then you, after deleting it, we will reinsert all of that successfully. So click on the delete options, delete the beams and the ribs as well. So this side do the same thing, beam and ribs should be deleted. Okay, so we delete that, yes options or okay options. So we need to create a normal beam at a normal level. At first, property, pick the first point, right, and have the beam covered just like that. Okay, come over to this side and you connect the beams instructions successfully. Then for the slab right there, we can select any of the ribs, right click, it properties, we used it here and here. Alright, just like this, closed this dialog, and then navigate to the 3D. Let's see the way it looks. So you will be having something of this kind now. Alright, so having something like this now, you have to now slope it in a way that is going to be at the same level with the second floor. Alright, so we navigate to the plan view of the second floor, and then we get to the modeling, come to plane definitions. We have to place another plane here, which is P1. Okay, this is for story 2. Alright, so over here we need to set set the points successfully. So we have to move point 1 on the plan definition dialog to this provision. So zoom closely to pick it correctly, and then point 2 is already in place, so there's no need to check point 3, which is going to be on the normal story 2 levels. Okay, so we change the point 1 prefix minus 1500, okay, which is this sloped. All right, so the same thing applicable in the point 2 successfully. 1500, click on the update, close this dialog. So you will have to select this again to enable the property, and then we use the property in these provisions as well. Click on the close options right there. Let's navigate to the 3D. So we click right here, 3D. Right, so we have something of this kind, and then we navigate to the story 2, and then get to where you have the planes right there. So we have P1, P2. You have to move members to plane. Yes, options to move that successfully. You can see. And then the same thing applicable to P2, move members to plane as well, just like this. So see, everything is now in line successfully. For the columns, we have to remove the plane constraints. So select all of this column or the control key to have the multiple of it selected successfully. Right click and then property over where you have DZ top, select that to remove the constraint of minus 1500, change it to 0. Successfully close this to have the columns, and then you have to check through these columns to make sure that it is not overlapping. Okay, so none of this is actually overlapping. So having gotten here, we are going to be generating this story 2. We'll be generating the story 2 to story 3 successfully. What we need to do now is we have already set the stories. You can see we have up to story 3 right there. So select on the stories, right click, and then generate story, and then from the source story 2, and then the target story is going to be story 3 right there. So at story 3, we wouldn't have some of these structural members or elements. Okay, we need only beams and columns right at the story 2, because it's going to be used as a roofed level. All right, so we will have to proceed. Click on the OK options to the yes options, and then that will be generated successfully. So we have something of this kind. All right, so what we just have to do is to remove the constraint, the plane definition constraint on these roof beams successfully. All right, but at first there's something that I would like us to do at the second floor. So navigate to the second floor. We need to change these column sections so as to fight against story draft check successfully. So we get that selected, expand the columns, select the first one or the shift key, and select the last reinforced concrete column at that level, so you have something of this kind. Okay, so right click and then click on the property. So in the column property, we have our sections to be 500 right there. Change these sections to 450 right there. You can maintain the width to be 2 to 5, okay, but we need to change this to 450, and then you type 450 right there, 450, just like this. Click on the OK option. So this will be changed, but this is going to affect the orientations of the column. I will show you what to do. So this is what I meant. You can see the orientations of the reinforced concrete column has actually changed. You can see. So this, okay, is not maintaining the orientation we had at the first floor. So what you have to do in this case, select the columns again, and then change the angle of rotations to there is the angles of rotations. This one we change it to 90 degree. All right, so select that 90, click on the OK options. All right, and then all will be aligned successfully. You can see now it's been aligned. All right, so at this point I want to also invite us for our ongoing master training program, okay, on Protastructure, Tekla structure, and other software like Revit we are using on this channel. Okay, we will train you to be advanced users of this software successfully. You can see a link in the description of this video. You can contact us through our Telegram links right there, or WhatsApp as well. Okay, let us make progress. But by then, don't forget to give the lesson a thumbs up and subscribe to this channel, Freezing, as we will continue to bring to you a very useful content of this kind. We proceed. So we navigate to the story 3 right there. At the story 3, we need to be changing these column sections as well. So we expand the columns, members, select the first one or the shift key to select all of that, right click, select the property, and then we change this section from 500 to, we change it from 500 to 400 this time around, or we can still maintain 450. Let's go by 400 right there. So click on the OK options. Alright, so this may also change the orientations of the columns. You can see orientation being changed. So you change from this angle provisions to 90° right there. Click on OK. So this will be applied successfully. You can see, close this dialog. Now we'll remove this constraint. We're now going to remove the constraint of these beams. The constraint of plane definitions has been affected these beams, that force it to be slopey the way you see it. Alright, so we need to remove the constraint so as to have it on a normal level or a normal plane level. Click on its property. So in this property dialog, let's check the DZ, its provisions. Okay, its constraint of 1500 is affecting the beams. Change it to 0 right there to have the beams at the normal level. Also change this to 0 right there, just like this. Okay, I believe everything has moved to normal level. Okay, so click on the close options. Then these other two beams we have in there, get rid of that by deleting it successfully, just like this. Okay, so we have something of this kind. Alright, at this point we are going to be modeling our roof, but by then we need a reinforced concrete slabs to cover and close up these provisions successfully. So we can navigate to the plan view of the story tree, just like this. So at this point, select reinforced concrete slab, give it a thickness of 150 right there. Cover is 22, cover is 25 millimeters. You can use a room in these provisions, and then can't make use of that in post loads. So we have this and have this, but by then we may just place this here so we can use its property. There are some changes we need to make here. Remove these beams. This is a roof beam. Okay, so there's no need for that beams. Okay, remove this one as well. Okay, so use this property that we have already set to place a slab here and here to cover up the top of the stair room. So here, remove this. Okay, so this is the ceiling level, sorry, the roof level. Okay, alright, so I have something of this kind. Okay, you can as well make the slab solid so you can see it very well by navigating to the building setout, come to layers, properties, settings, and then come over to where you have slab ash right there. Change this to this one, make it a little bit darker. Okay, options, so you have this. Alright, at this point we want to be modeling the roof truss. Okay, so the roof truss is going to span from this point to this point. Alright, okay, so we navigate to the modeling provisions, but by then let's save this project. Having saved the project, you get to the truss right there, click. Alright, we pick the first point, section point at first, come all the way to pick the second section point. So we try to place it correctly. Alright, so this will take us into the truss dialog, just like this. So we'll be using this type of trusses. So presently we have an angle iron here. We are going to be changing the members, so click top cut right there. So we'll be using arrow HCF option properties. We use 80 by 4. Alright, 800 by 80 by 4 thickness. Select that. Alright, click on the OK options, and then click on that again. We will need to change the orientations to 90°. OK options. Alright, come over to the bottom cut, the same property sections. Okay, select that, change it orientations. OK options, and then for the diagonals members we will be considering square sections. This, okay, we go by 70 by 70 by 3 square sections, and then for the verticals members we use square sections as well, the same section, 70 by 70 by 3 right there. Okay, alright, then come down, see the horizontal, although we wouldn't have horizontal in this truss, so we still use square sections for the horizontal, 70 by 70 by 3. Right, okay, options. At this point we get back to the general, so we can carry out some settings. Okay, truss support placement is going to be bottom and not top, like this. Okay, So the left cantilever length of the truss, we have it to be 1000 millimeters for clouding, just like this, you can see. All right. Also, we scroll down, so the apex height, we change that to 2000 millimeters instead of 2500. Okay, the left heel height. Okay, this is this left heel height will help you to have a clear depth for the concrete fascia. Sorry, for the fascia board. All right, clear depth for your fascia board. So fascia board is always between 250 to 300 millimeters. So you can do that. Key in 300 millimeters. You can see the changes on the truss right there. So the truss spans is going to be like 10. Okay, so we have it to be 10 right there. So okay, so we proceed, come down, top and bottom chord, top chord left extensions, we wouldn't have that. Okay, so I think everything is fine with this truss that we have set for now. Click on the OK option to place it just like this. You can see what we're having like this, so we continue to place that. Okay, can as well have it here. So right click to get rid of that command successfully. So we have our trusses being set out just like this. We proceed now to place the polines. Okay, click on the polines right there. Pick the first, the last one to enable the polines dialog just like this. So the profile of the polines will maintain 100 by 50 by 10 successfully, and then we have to check for a left cantilever length. So we need a left cantilever length of 1 meters, and then right cantilever length we have it as well, 1 meters. All right, okay. After which we just have to check the loadings. So we have to apply the load on this. This is where we should apply the load on the polines that will be used to design the truss. Okay, so how do you do that? If you check in this position, there is nothing, so you have to click on add loads. For this version of Protastructure, you need to click on add load. So if you click on add load right there, you are supposed to have a load being added here as the date and life load successfully. But if you notice it's not working, why is it not working? Is because we have not enabled the loading combinations. Okay, so before you should add a load to the structure, you must enable loading combinations successfully. So we have not done that. We'll come back to it later. So click on the OK options to insert the polars like this. Okay, so we proceed to save the project. Having saved the project, we will have to enable the load combination. Come to loading tab, options right there, click on the load cases and combinations. Click on the loading generator, OK options. Okay, to enable the loading combination successfully. Click on the OK options right there. And then if you want to now add the load now on the polines, you can get the polines selected, and then you right click, select each property. So now come to load provisions. You click on add load. Now you can see we are now having L1 as the load levels. Okay, and then you see we have the selected load cases. We have over here the G load, we have the Q load because we have enabled the loading combination successfully. Okay, assuming we also enable the wind load loading combinations, we could have been seeing WX, which is wind load in the X directions, and WG successfully. Alright, so let's go by these loadings. We have this to be 0.1 right there for the dead load. So after you must have having this successfully, what you just have to do, click on this, select the L1, click on the OK to have it added successfully. You can see. So the next one is the Q load. Add that successfully. Come to these provisions. We have here to be 0.09. Okay. Come to these provisions. Click on the L2. Click on OK options. It's been applied on the roof poline successfully. OK options. Okay. So we loaded the poline successfully. All right. We proceed. Get to the modeling tab, and then we need a clouding right there. Then select this polines. Make sure the polines is selected to be able to place your cladding. You can provide thickness of your cladding. It can be 0.05, which is the thickness of the roofing sheet successfully. Right, so you can also use the cladding to apply loads, but we have already applied load directly on the polines. Okay, Assuming we didn't apply load on the polines, you can as well apply load. You can see all the loading provisions right here, right, on the clouding. And then clouding actually helps us. It's just like a referee sheet, transfer the loads to the polines and to the roof trusses successfully. Click on the OK option. So we have that successfully. Alright, so we proceed to setting the materials. So we have to get to building setup, come to materials right here. For the concrete strength, we will be considering 20/25. Okay, this concrete strength gives us the mixed ratios of the concrete successfully. We applied it to all of these structural members. Click on the OK options. Okay, get to this steel strength. Alright, so we will be considering 410. Okay, which is a yield steel. 460 is a tensile steel, and then 500 is high tensile. Alright, so it depends on the strength we actually wanted. We can go by this yield steel successfully, and then 250 is a mild steel. Alright, so apply this to the structure. All of the structural members, click on the OK option. The diameter reinforcement will be minimum of 16 y16 right there. So the y16 for the columns. Alright, so we know 32, we have 25 and 20, 16 for the columns. Alright, we already have walls here, we have beams, so we also select 16 as the minimum, and the maximum 25. We uncheck 25 right there, uncheck 32 right there. Click on the OK options. And then for the links, we will be using y10 as the minimum and 12 as the maximum. Uncheck the rest of these successfully. Click on the OK options, and then at this point we have the slab right there. For the slab, we will be considering 12. We're considering 12, and then we also used 16. We used, because we have ribs right there, so we use 10 right there, 12, 16 right there. Okay, we may use 20 as well. The program will have to select depending on the loads. Okay, after having done this, come to the foundations. Okay, and then the diameter we'll be considering is 12. For foundations, we reinforcement 16, 20. We also have 25 right there. Okay, click on the OK options, and we get back to click on the OK right there. Then we want to go and do some little settings. So we get to settings to actually select the maximum and minimum diameters of reinforcement to be used in this structure. So we use 16, we use 25. Okay, so the 16 minimum for beams, maximum 25. Alright, so for the links, minimum is 10, maximum is 12. You have to do this successfully to enable the programs carry out designs effectively. Alright, click on the foundations right there. In the foundations, you have a square footage set it to default. The solid capacities, you have it to be 150 kilonewton per square meters. The minimum footage is going to be 1000. All of these are adjustable. I wouldn't want a top and bottom footings reinforcement, so you have to uncheck all of that provisions. Okay, so after which we click on the OK options, and then we save the project. After saving the project, we will have to navigate to analysis tab. Click on the building analysis. You check the project parameters. Here are the codes we're using. The foundation, we've already changed it to 150s. You leave the lateral loadings at default, lateral draft at default, and then the title, key in the title of the project made by, right? And if you have to just fill in these provisions successfully, click on the OK options, and then the material we have already set it, so you can just have to check that back again to see. You can see everything is in place. Alright, so at this point we can as well get back to the analysis tab. The analysis tab, having everything in place, we want to run the building analysis now, so we click on the building analysis, and then we are not going to design, so you have to analyze first. So you give the program some time to be able to carry out the analysis of the whole structure successfully. So when you are designing, when you're analyzing a structure that have a slopy system, you will have this build analysis warning, all right, which is trying to tell you that not all the nodes that are on the same plane. That is what this warning is telling you, trying to let you know that the program is going to design those nodes that are not on the same plane, okay, as to be on the same plane. They are taking it to be like those slopy slab, right, is going to be designed as a normal slab, okay. So you just have to hit on the okay. So the program proceed with the analysis, okay. All right, so we also have this, okay, the axial load comparison warning, okay. So meaning some of the load system is actually lost, okay. So due to the modeling and how we also generate the story successfully. So this is just an axial load comparison warning. All right, we will check on that successfully. Click on the OK options, and then build analysis is completed. We click on the close options. So this has actually taken us to the analytical model, just like this. You can check the displacement. You can as well check the diagram, which is the bend moment right there for the structure. You can see it just like this, okay. All right, let's get back to the stories tree right there, and then at this point we want to be designing the whole structures, okay. Most of the warning you see there, we explain them extensively in the master's class. All right, so we advise you to join the master class successfully, so you'll be able to get a full knowledge of that. Although there are some videos that actually explain that on my channel, you can also check that. But for this structure, I've corrected it successfully. All right, so we make progress to design the structural members, the beams. So you can select the beam right there, and then you get to active story or use this. So this has not been designed. You can just use batch mode design. So select all bars, calculate. So this is going to design the reinforced concrete beam members of the structures. So we close that. See, all the beams is being designed. You can now carry out the interactive designs of the beams, okay. All right, click on the close options. That aspect too, we teach it extensively in the master class. All right, so for the columns, you do the same thing. You have to use these options, expand this window, and then batch mode design. Click on the close options to have all of this design. None of the columns is valid, but this one, the U ratio is 1. This one, U ratio is 1, which is stressed up. You can as well change the sections to counter and correct this successfully. All right, but we actually explain this as well very much and extensively in the masterclass. You close this. All right, so we are done with the analysis and design of the structural members. Because as well as check the steel members, right click and then come to steel member design. So we have this. So this has not been designed, okay, so that's why you wouldn't have any things, and statute is not showing. So you click on the just have to select this check all members right there. So the check all member will have to design this. You can see everything is designed and everything has passed design successfully. This truss has passed design successfully. Right, click on the OK options. The same thing applicable to all the trusses. So we have done with analysis and designs of all the members in this structure. For the slabs detailing, you can navigate to let's say story 1 right there, and then enable the plan view of story 1. So with this, you can draw your slab strips successfully. Mind you, for you to generate reinforcement for these ribs, you need to carry out FE floors analysis, which is the finite element analysis. We may be doing that in this video. Alright, but for the slab, get to the modeling and then click on the slab strips. Alright, so in this slab strip, we're using an analytical strip for this slab. Then we use finite element strips for this this slab with slopy properties. Alright, so we go in the X directions. At first, pick the first point, hold the control key to have a straight line. Let's start to design the slabs reinforcement. Just you can see right there. Okay, so we move to the Y directions. Okay, using the same boundary conditions or limit statutes bob to bob, which is out to out. So here is supposed to be out to slab because we have a slopy slab here. So you choose this second option, this first, second, start and end right there. Or the control key to have a straight lines. Need a straight line, all right. Let's get a straight line, can't escape that, and then do it again. Y directions and then start, end. So pick a point, go a straight line like this and place that, just like this. Same thing, place that, right. Just like this. Okay, so we design that. We have to place it also in the provisions and this other provision in the same way. Click on the close options, and then at this point we can now proceed to designing the ridge slab using the finite element method. Okay, so save this project first. But before we go into the finite element analysis and design of this structure, I want to let you know one thing that is very important. When you want to design a finite element analysis, you have to start the analysis using the load test down method so that there will be a proper distributions or the compositions of the loads on the structure successfully. Alright, so you also take notice that in this structure we wouldn't have anything like a wall load because there is no provision for walls. Actually, there is no provision for walls other than railing is what we have on this structure. So if I navigate to the 3D now, you will notice that we already have a wall load. So what you can actually apply, you can apply a railing load on this side of the pavilions successfully. Okay, which is not much. So let's get into designing the ridge slabs using finite element method. We get to the floor level of story 1 right here. So what is necessary about the strips, finite element strips right there, is that you have to use the FA straight options in the slab strips dialog, and then you select the right directions, okay, according to the boundary conditions or the limit stated successfully, after which you come over here. So in this case we use this type of strips, but you're not drawing strips now because we have not run finite element analysis. So I just want to explain that to us. We get to the analysis tab right here. So this is the FE floors analysis will be carried out. So for us to, before you click on it, navigate to the last floor. You have to be on the roof level right there. Click on the FE analysis, just like this. Okay, so you see the story level is story 3 right there. So we can't use the FE floor just down analysis. Okay, you use these options, but before then you have to reduce the stiffness factors of the slab to 0.25. all right. So once you do this, you can go ahead and use this method. But I want to show us something, how this thing is being chased down successfully. So let's do this in the 3D. All right. So most of the time we actually teach this very extensive in our master class successfully. So I will put this in this direction, just like this. Then I came back to the FE floors analysis. I move this dialog to these directions. So why I do this is because I want you to observe the movement of the grid lines as it will be testing down the load successfully. Alright, so we will click on the FE floor chest down analysis. So at this point you have to check the slab's stiffness factor. You see we still have it at 1, so you have to change this to 0.25. do the same thing here, 0.25, and then here also is 0.25. So having changed the slab stiffness factor successfully, we will click on the OK options, and this will ask us to pause and check the analysis result first, but we really want to do that. We have to continue straight away. So this has started the preparing the finite elements models processes, right? So here is at level 3. Okay, see it has moved to story 2 right there. So I click on yes options to continue. So it is going to analyze and as well move the grid line to the story 1 as it completed the analysis successfully. So here at story 1, you can see over here story 1 FE slab analysis completed. So everything is being analyzed successfully. Let's see. Click on the OK options. So this will actually transfer us to the post analysis processes. Okay. So before you run the post analysis processes, you have to now proceed to make sure you draw the strips. Okay. So we close this. So having closed this successfully, you navigate to the plan view of story 1, just like this. So after which you get back to the modeling strips, slab strips right there. Then you can be able to change here to FE strips. We move in the X direction first, and then we are starting from outside to outside, which is bulk to bulk. So choose these options, get to FE, select this second options of the FE strips, pick the first point to draw the strips right here for the Raft slab. So you have your strips drawn like this. You notice we didn't have any warning right here. So after you must have drawn your strips successfully, click on update, and then you close this at this point. You can now navigate to the analysis tab again. Click on these provisions, get back to this point, and enable the analysis post processing right there. Okay. So this is where what we have here. So you can click on the contour right there to have the contour generated successfully. So this is the contour key where we can be able to read the intensity of the loads depending using the color plates right there. So we have to carry out the bending moment check, alright, and then design moment as well. After which we carry out the required area of steel. So what you see in here is the area of steel, okay, at the critical point. Okay, so we use that to design the finite element analysis. So we can also be able to export contour, and then we can as well edit. If you want to use this user-defined contour, you can use the user-defined contour to be able to create our reinforcement successfully. But most of these options we teach them extensively in the masterclass successfully. So we proceed. Okay, so having carried out the design successfully, we click on the close options. So to draw a strip, click on yes options. Alright, so that is done. Close this option. Right, so we have done with the design of the ribs. So if you want to see the rib beams, you can go to this design options and then come to rib beams right there. See, we have this beam, so you can click on this. We calculate and design that successfully. So this has been designed successfully. Click on the close options right there. Okay, at this story 1. So everything in the structure, all of the structural elements has been designed successfully. So get back to 3D. The next thing we'll be looking at is the foundation design. Alright, the foundation design of this structure. So it all depends on how you want to design the foundations. So the designing the foundations, we'll be looking at 2 types of foundations here. We'll be looking at the combined part footings, okay, and we consider as well raft on beam, okay. So we can just navigate to the plan view of the foundations, double click on the story 0 right there, and then enable the plan view. So we'll be having this area. This area is going to be taken by the raft on beam, right? So we can also support the raft on beam with pad as well, if necessary. But this for the sake of lesson, okay? So making you understand how to make use of most of these options of foundations. So we will get to modeling tab right there. Rcc member design, pick right there. For the beams, you'll be using sections 250 by 1100, which is the foundation height. So we just connect the beams successfully. just like this. So having done this successfully, close this dialog. So we'll be having our slabs, okay, a raft slab on top of this beam. Okay, so for us to do that effectively, you need to know the depth of the foundations and the thickness of the slab. So by the time you minus the depth of the foundation from thickness of the slab, you should be able to have what is obtainable to be used so as to place the slab inside the slab accurately. Okay, so you click on the RC slab right there. So the thickness is going to be 200, and then the relative level we'll be considering is going to be 900, because 1100 minus 200 give us 900. All right. So with this, we can be able to place the or insert the slab at the accurate level we actually intended successfully. Just like this. Then you can navigate to the 3D to see what you've done. Just like this, you can see it's properly placed successfully. All right. So with this, these provisions, we will design this as a combined footings. All right. So select the two columns, and then you insert the combined footings. You notice we are having some failure in this reinforcement in the y directions. Okay, this is choosing 13y20. All right. So how do you get this done? We can decide to increase the sections in the y directions and see if that could change that, but it's not changing it. Come to the rebars. So we try 25 right there. So we see we use y25 to actually correct the failure right there successfully. So most of these tricks we expose them in the master class. So we encourage you to join our master class to actually learn how to use this program effectively. Okay, so the footing thickness, if you come to the geometry, see the footing thickness increased to 900 millimeters, right, which is fine. Click on the OK options, and then we have the footings being inserted, just like this. You can see. So over here, you have to select this, right click, and then insert combined part footings. Okay, so we have the same failure going on there, so we want to increase this as well to 1400. Right, come over to the rebars right there. It is failing in the y directions. If you take note, so increase this rebars right there. Okay, so because what is happening there is just like a punching, the rebar are not enough, so everything is fine. As you can see, click and create a report as well. Click on the OK options to insert that footage right there. Okay, so along these beams, we can also create strip foundations along these beams. Strip foundations so that it can provide a clear distance that will be able to cover the entire area of these columns successfully. So if you want to do that, you get that this beam selected, come over here, right, or you right click, and then you see an options over here to insert a strip footings successfully. And then in these provisions, you have to use the design envelope, which consists of the loading combinations successfully, and the rebars. Okay, you can select it over here, after which the left hand side cantilever, the right hand side cantilever, just as you want to actually extend it. Depends on you. You can use 1.2 or 1 meters, but it's minimum of 1 meters. All right, click on the design right here. So this will design the strip footing successfully. Click on the OK options, and then you click on the OK to insert the strip footings, just like this. Okay, this will actually help you to strengthen the foundations successfully. All right, so this we have designed successfully. So if you check the ground beam, you notice that this ground beam have not been designed. So we always see ground beam, come to design right there. You click on the foundation beam, this one. So here are all the foundation beam we inserted recently. You can use bash mode, design right there, select all by calculate, right? So we close this has been designed successfully. Let's see. So after which, carry out your interactive design. We normally do this in the master class. All right. So after having done with all of these design successfully, we can now proceed to generate drawings. Okay. So we generate our drawings. We go to the drawing and report tab right here. So at this, you can use a Protastructure to generate your drawings successfully. So click right there. So yes option to save the project first, and this is going to launch Protastructure successfully to generate the design drawings of this structure successfully, including foundations. Alright, so we give the program some time to carry out that successfully. So here we go. Here is Protastructure, and then we are going to be using option auto generate details. Click right there, and this will open the draw details dialog. Okay, here in this scale we're considering 1:50. Click on draw options, and then in the scene environment just click anywhere, and then give the program some time to generate the design drawings of the project successfully. So it's going to generate all the drawings, including the part footings drawings, the columns drawings, the beams drawings, all will be generated here. So the process is completed. So if you zoom close, you can see all of the drawings right there. Okay, just like this. So you can see the slopey. Okay, with this you can be able to check the elevations and produce your drawings accordingly. So you can see the reinforcement generated in the beams as it slopes. Okay, this one is carrying 3y25. Okay, you can see top and end 3y20 at the bottom right here, and how it slopes and the reinforcement. You can see everything just like this. So as I said earlier, this is a real life project that we actually designed successfully. So here are the beams, okay, that forms that staircase provisions. You can see over here. Alright, so everything is being generated successfully. In the part footing foundations, we have the raft beam foundations just like this. You can see. Okay, so here is the drawings for the project. So the next thing is how to edit these drawings successfully. So I will be introducing you to a Protek company detailing templates. So this will help you to detail these drawings and edit these drawings at ease. So if I minimize this, we open up AutoCAD. Here is Protek company detailing template. This template has an already edited real life project drawings you will see in here. So we also have a pile. Okay, so here are piles. Okay, and the drawings of the piles successfully. So if you get this template, it will actually helps you when it comes to some of these type of foundations drawings presentations. Okay, this is great beams for the pile successfully. We have this. I've designed a rib slab before, so these are the details of the ribs. Okay, it's also in the template. The link to get this template is in the description of this video. You can always get it through the link. Click on the link, and then you'll be able to get it download. It's just a small money you will need to pay right there. Here is also a raft on beam foundations for this structure I did. Okay, and here is the drawings, can serve as a reference drawing, but this template is being customized in such a way that let's get back to the Protastructure. So we'll be generating this by converting this to DSF file. So select DSF, right click and click on export. So we use version 2010 to export it. Click on export. This will open the directory of export, which we will proceed to launch it in AutoCAD and see how effective the template will actually help us to carry out the editing successfully. So here is the drawing. Double click on it, which it will open in AutoCAD. Click on continue opening the WG file, and then it will open just like this. So as you can see how the drawing looks here. So for instance, if I copy just some part of this drawing to the template, you see what changes the template will make to this drawing. So I selected this one. You can see how it is. I right click, and then on that clipboard, click on copy, come to IC Protek engineering drawing template right there. Paste this here. So if you zoom closely and then you paste it, yeah, you now see the way the drawing looks here. So if you come to the drawing itself, see the way it looks here, right? Then the one that's in the template, you can see how it looks. So here are the changes and the editings that this template will help you and reduce your workload up to 75% successfully. So I will advise through the link in the description of this video, get this template, and then you can always reference this template, okay, and make use of any of these drawings, okay, in order for you to fast track the editing of your own drawing successfully. All right, so this is just an example of what the template can do to the drawing to ease your editing experience of your structural drawing successfully. I will be deleting this up, so I will click on erase right there. So what you're supposed to do after taking this to AutoCAD, you have to select all of this, right click right there, and then copy it to clipboard right there. Okay, navigate to the template, then I have to paste all of this in the template successfully. Ctrl V, click to paste the drawings, just like this. Right, so having pasted the drawing, you can see how the drawing looks here. Everything looks fine. The rebars has been added some weight. Okay, the text has been also increased in text height successfully, unlike when you have it here. Look at the way it is here. Right, now come to the template. You can see the way it looks here. So this template does wonders to your drawing. So now editing will be as easy as possible. Alright, so you cannot proceed to edit and then arrange your drawing for final printings. Yeah, we come to the end of these presentations. If you also check in the link in the description of this video, you will see KCSOFT staircase design. You can also get that to carry out your staircase design successfully. Alright, so thank you for staying through the presentations. Don't forget to like and subscribe. Don't also forget to reach to us, so you can also consult us with your various designs, okay, using any kind of foundation at all, tile foundation, raft on beam, floating raft. Alright, you can always consult us. Alright, we don't charge that much. We'll help you to carry out and complete your project structurally based on our years of experience in this field of structural engineering. Okay, and we also invite you to join our ongoing masterclass. If you want to become an advanced user of these programs, both AutoCAD, Protastructure, Tekla structure, and the rest of the programs we'll be teaching on this channel Sofrism, join our masterclass, and then we train you from A to Z, both the steel aspect and the concrete aspect. Okay, so thank you, stay safe, stay connected, and see you in the next presentations. Bye for now.